Power resilience is the foundation upon which the entire industry is built, but as the rack densities climb, UPS systems designed for previous generations of infrastructure are being stress tested in ways that designers never foresaw. Joining us to explain how we bridge the gap is Danel Turk, Data Center Solution Architect at ABB. Danel is going to walk us through exactly what the UPS architecture needs to look like and to support the relentless demand of the AI era. So Danel, welcome. I'll pass the floor over to you.
Super, thank you, and I'm really happy to be here and elaborate a little bit more. Where do we come and where do we go as well? Let me
as an
see.
Industry.
Yeah, let me share my screen. So let me walk through then a few of the things. Where do we come? Okay, super, thanks. My name is Turk. I'm in ABB Data Center Solution Architect, and what does it really mean is we help the customer to adjust the new strategies, to help the customer design electrical infrastructure, to be also ready in the future proof, and try to optimize and help to optimize really as well. I will walk through today not only the UPS and backup power, I'll also explain a little bit where do we come, why does the critical power is coming also more important, and also a little bit of people and competence availability, and what does challenges it will bring to us as well, and definitely stop on the backup power and what options do we have today available as well, and what will come to the market as well. If we keep going ahead, first of all, the data centers has really went up from like 15 years ago when we started a little bit bigger data centers. It was the rack sizes, we talked like a 3 kilowatt. Today, the rack sizes, we almost talk in the 3 megawatt range, or somebody even a little bit more wilder ranges as well. But really it has went up significantly. And that also means that the data center sites has went up from few hundred kilowatts up to the few gigawatts as earlier speaker showed as well. What that will bring is that will bring a lot of challenges on the power. So how do we really can power the data centers? And the power question pops up in every discussion as a first few questions, especially in the Europe side as well, but it's the same all over the world. If there is availability for the power, basically you can start building your data centers. And there are many ways to get the power. You can see on the right side pictures as well. There is a lot of renewables. There are battery storage that could help to mitigate some of the power issues, the generators or the fuel cells, and definitely grid as well. And all those changes actually change also the architecture, which makes the future architecture also a little bit more complex than it maybe was 10 or 20 years ago. But there are opportunities to also improve and get a better efficiency as well. And on the way forward, we also see a clear trend that products is not anymore as they used to be in a way, but it's more of the solutions discussion. And ABB and other companies definitely are looking at that and supporting that approach. And I will later stop a little bit more also why this solution approach is much better for data center industry going way forward. And really, all these discussions are impacting almost every element. So I already touched a bit on the power generation. It really depends where your site is and how much of external power you can also get in, or do you need to do on-site also quite a lot of power generation as well. On the critical power components, I will stop longer later, but there are many different ways how to protect your processes and how to protect really your site as well. There are definitely coming up a new high runner product like a medium voltage UPS, which can cover your backup power for the whole site level. There is good old low voltage centralized UPS. There are battery energy storage that has also went through in the last 15 years. quite extensive development phases as well on the power electronics, but also the chemistry and the battery side as well. We still see time to time rack level UPSs, and now also going way forward with the new technologies and the direct current coming, also more data centers, short-term storage with the super caps or different technologies can be an option as well. And that will trigger a lot of new questions as well. Should we stay on the usual 10 or 13 kV range, or should it be moved up to the 36 kV? There are significant benefits going on the 36 kV, but it will require a little bit pre-thinking and a little bit changes on the architecture as well. And then also the question is, what are the more alternatives that can be done? And one of the hottest topic today on the table definitely is the direct current option. And the people in the industry has seen the direct current popping up like every 5 or 7 years. And today with the technologies available and the materials available, the direct current entering to data centers more is really there. So it's really viable what we can do. And here is a little bit of simplified view just to show, if we consider day zero, that's what we have done in the last 20, 35 years on the data centers. And everybody knows how to do it. It's a medium voltage feed in, it's a AC network with the UPSs, with the PDUs, with RPPs, and down to the rack. But if we go with a higher power, then we need to do some things differently to get the better efficiency, get the better modularity or replicability. And only way going ahead is really on the DC. So we can really cut off few of the conversion steps as well. So the day one, the best option would be with a sidecar, which is released by the OCP, where ABB is also present with other industry players, and of course, NVIDIA as well. And all these architectures are following the industry approach as we go ahead. So the sidecar is the best and easiest option. And later, if you already have a existing AC infrastructure in your data center to do the brownfield, you can also do the with the sidecar. You can also utilize that as well, and it really works pretty well with racks up to 500 kilowatt as such. They do. The discussion is more on the rectifier unit. You can see a little bit of change here. There is still transformer in rectifier unit, but down from rectifier, there is also already DC network. It's somehow new, but actually somehow old as well. The similar concepts and architectures are used also in the marine last 20, 30 years. All the bigger cruise ships where people are going and driving around are also based on these technologies. So it is industrialized, proven, and the technology is there to go ahead. And of course, the beauty is the day three, the top goal is to have a solid state transformers in a various ratings, still debates on the market, but solid state technology with a transformer, also with the solid state breakers in the DC side, that would be the end goal and most efficient goal as well, to be fair. And these rectifier units are pretty good with the 1 megawatt rack sizes, but the solid state will be definitely more efficient, less steps of conversion, and the racks from megawatt and above will be really efficient there. So a few things more on the AC-DC comparison. I already mentioned that all those elements will be there in a coming year, and AC still have its own place. It fits where you have already the system and you want to just upgrade the racks. Makes sense to stick to the AC or put a sidecar in. It depends on the rack sizes. But if you build a new site and you really know what you need to do on the next cycles, DC definitely is an option and way to go, and think already about it as well. And if you have a battery storage renewable on your site as well, it all will benefit from there going to the DC. And a DC will have a less conversion steps, and it's much more, or 5%, which is quite a good percentage, is more efficient in the data centers. If we look a little bit on the backup power, and if we stay a little bit simplified way, on the left side, you can see how the grid operators would dream that the data center power looks like. However, if we look to the high compute loads, we can see what happens on the right side as well. So you can notice that there is a little bit of gap what the processes are and what the grids would really like to expect. And when the data center sizes, we're talking about the hundreds of megas or a few gigas, we cannot afford that those are dropping on and off. So utility is not able, or transmission lines don't really cope with that very well, unless they do significant investment, which is not reasonable either. So there is a lot of things that the data center builders or operators can do, and to consider the smooth peaks or keep the solid loads is really best for the grid and the power grid definitely as well. There are already a number of regulations in the place as well, where to get the utility connection as well, it's important that data centers are installing either battery storage or a fast response equipment. So if anything happens on the grid or happens on data centers, they do not disappear from the grid connection. So battery storage in that sense is getting additional good discussions and the grip there as well. And of course, grids don't like any of the harmonics or any of the disturbances. So any clean power that's connected to the grid, they are okay. And a solid load, the better it is. And to be fair, there are technologies available that can really make those curves like the grids would like. Just needed to be chosen the right technologies to be installed on the data centers. And here is few of the options that are available for the smaller data centers or smaller rack sizes as well. There are one-phase or three-phase smaller power UPSs available. But if we really talk about the big data centers, 5 mega above, 100 mega, 1 giga, then the more we go to the right, the more beneficial those products are. So if we talk about block sizes of the 2 megawatt or 1.6 megawatt UPSs, then you can really benefit on the modularity point of view, and you can also benefit on the doing the standard blocks and standard sizes on your data center. But in the most far on the right, you can also see the medium voltage UPS as well. I'll stop a little bit more on this one. It's the newest technology, and it can really support also the grid as needed. So if there is any disturbance on the grid, it can also help the grid as well. So the data centers are more future-proof there as well. And if you remember the earlier slide with different day 1, 2, 3, 0 networks, utilizing a medium voltage UPS, that means moving away from low voltage to medium voltage level, it will also help to keep your site future-proof, because whatever technology you may use later in a different rack sizes, or will it be DC, will it be different DC voltage levels, it's if you install already your medium voltage UPS, it doesn't matter how you design your last mile. So you are already protected on the medium voltage UPS, on the medium voltage level. All changes you can do later on, but you can start building your site if you have the power and the connection availability there. So on the medium voltage UPS, it is according to UPS standard. So it's not really only the battery storage with a step up or step down transformer, but it really fulfills the UPS standard as well. It is scalable. It comes with a 2.5 megawatt blocks, and you can really build it up 10 blocks in parallel, so you can do 25 megawatt blocks. And if you consider that it's the same power that you need in a low voltage UPS, there are significant benefits and savings. I'll show on the next slide as well. what will come to you with this new opportunity or this new product or option that is available on the market. As I said, it also comes with a grip support services. And one of the things is definitely the shaving the peak with a lovely and beautiful AI load that sometimes are a little bit more challenging. We have also done in ABB the testing with the AI curves and the loads, and our UPSs can cope it very well. And most of the cases, we don't even need to involve the batteries on the smoothing, so that will keep the battery health in a much better, decent level as well. The medium voltage UPS also, the beauty is it comes with quite a high efficiency in the level of 98%. If the load is between 50 to 100%, and usually data centers really run on the 50 to 100% load. And if it's on the medium voltage level, then it's not that one of your racks is off and you're running in a smaller load. No, if it's in a medium voltage level, that also covers then the site level. So it's a lot easier to run it in the range that you really want to have. And comes with a 15 years lifetime design as well. So what will you get as additionally with the medium voltage UPS? The first, of course, is that it's a less units required. That means also less labor and also the less maintenance as well. If you think about that you need 100 or 1 gigawatt site, and you are using 4 or 3 architectures, you can do the number of UPSs really needed and how much maintenance would be needed on those units. So optimizing that and putting it to the one place instead of close to the white space, it's a lot easier to make service and the maintenance. So benefit is clearly there. But also the copper wise, there are much less copper required moving a UPS to the higher voltage ranges. So we have done the calculation, and the 14 times less copper on the cabling or busways are required in the downstream. And in the medium voltage, it's also the uptime is quite high and more reliable on that level. And we can go up to the 35 kV solutions as well. And all those benefits on those boxes definitely comes down to the CO2 footprint as well. And Europe is getting more strict and strict on the CO2 footprint and also the requirements there as well. But there is still things to consider because I showed there are a number of different technologies available on the market. And when you think through your data center and your mission and what you want to serve and how, then there are things to consider, like, do you want to play on AI training? Do you want to play on AI inference? Or would it be for edge or telecom? That would drive what kind of solution and what kind of backup power concept do you really need. And maybe you need, if you do the AI trading, you may need like 3 nines uptime, or if you want to do something else, you may require 5.9 and so on. So it all really drives the architecture there as well. And also plan your scalability as well. Earlier presenter also said that there are different blocks. The most common block size is in a bigger scale is like a 3 megawatt unit, but it depends. It comes from 2.5 megawatt to 3 megawatt. So you can plan it. Then it's easier to replicate for the future expansions as well. And what we see in the future, in upcoming years as well, is that this is coming, as I said, very strongly. But don't worry, it is already available in many technologies. Railway, e-mobility, renewables, it's the same. So the technology is proven. It will bring new challenges with selectivity in your system, and it also will bring a bit the different architectures. But it's all doable, and there is no, it's just a little bit planning needed in advance. And definitely voltage increase may be in the future question as well. Today, the DC discussion is on 800 volt DC, but considering renewable is in a 1.5 kilowatt and rail, some case even 3 kilowatt and so on. So could be that the data center in the future will go higher as well. Power definitely will go up as well. And the standard still needs to be developed a little bit. So the new installation will be covered with the new upcoming standards there. So, but everybody's working on it to get on the market. I will stop a little bit also. Why do we need to go with a backup power or architecture, a modular approach? If we look few years ago, the data center average size built was 28 megawatt in 2020. And the average build-up time was 2 years. Today, the data center with a booming, the average size is 52 megawatt. You may think it's maybe too low, but considering there is a lot of telecommunication or smaller data center in the countries as well, and of course there are big hyperscalers built in the faces as well. But the average size is 52 megawatt, and build-up time has went up, partly because of the material availability, partly because of the solutions availability, but also the people and the resources availability as well. And if you see on the right side, the target is to go 100 plus megawatt as average, and the build-up time to come down 2 times or down to the 1.5 years. There has to be things done differently. So going more to the modular approach, going more to the solution approach would really help you to plan the activities on the site. As already said, today you would need the pumping guys, the electrical guys, the cleaning people, everybody on the site just to get the site ready and in a short time, but that will add complexity and will make a building time actually longer. And you need to take care of the safety and health on the site on those people, and it's not cheap either. So, and if we want to achieve the goal on the right side, we really need to think through and do things in a more optimized way. And in ABB, we have went through quite a number of studies and analyses and looked through the different options. And here is a comparison on the 3 options. The first one is a quite traditional stick build. So you make a building, you order the equipment in advance, but it gets on the site, you start assembling, you start doing a cabling. It takes the long time. So, but if it takes the second option, if we look into, is a prefabricated offsite. So what we could do in our factory is, in a parallel, we build all the components. In the same time, also the e-house or pod or the skid. We install the equipment in our factory on the skid, and we ship it to the site for the plug and play installation. And you can already start doing the cabling and prepare it on the site as well. So you can cut down the 30% cost there. It's not the most optimized, but it already gives you the benefit, but you can still make some changes, as that was the question earlier as well. How strict does it have to be? But if you look, the last option is that if you are able to standardize everything, you can do the pre-design, prefabricated, and you can cut down the approval processes, and also the service personnel would really already know what product they get on the site, in every site. So there is a lot of benefits that they come with. And just a few options on the different ports or standards available. You can do the medium voltage switchgear pod or e-house. You can do with a low voltage, but also with the critical power components in there as well, with the UPSs, or all in one as a quick, what we call quick deploy. And this is that you will have a medium voltage feed in, and you will have a UPS, usually comes with a 2 megawatt, or if you put 1.6 megawatt and 2 side by side, you can do also the higher power there as well. So there are options available that will help to get your site quickly up and running. And just a few wrap-ups. Keep in mind the power and power availability is really key issue in the 2026 and going forward a few years as well. Technology will evolve significantly fast. Think through like 10 years ago, iPhone 4 technology has changed significantly. It will go. Power electronics will really evolve as well. And that will come down to the backup power as well. Efficiency goes up, the power goes up, the power per square meter goes up. And it's a journey that we can enjoy all together. So I know the time was short. I tried to rush through a few of the things as much as possible. We're happy to always help on the different technical questions. And I hope you learned here a little bit as well.
No, it was perfect. Honestly, right on time. Everything was great. Thank you so much, Daniel. I appreciate it. We do have some questions, so I'm just going to quickly go on to it now. Bear with me one moment.
Sure.
Okay, so we got a question here. So you've highlighted that we're moving from a world from kilowatt to gigawatt, and that the AI processing creates massive, unpredictable dynamics. So how does that volatility change actually size a UPS system? And are we now forced to over-provision, or is there smart ways to design those spikes?
There is ways to design it, and if we consider the medium voltage UPS as well, then you don't need to take care of all the small spikes down in the low voltage or just right next to the rack. But if you also look, I showed in architecture as well, there is a short-term storage as an option as well. So some solutions or some customer prefer to put some super caps close to the rack to take care of this unpleasant stuff. And there are options that we can also take care of the higher level as well. If you look, we have worked with a medium voltage UPS in a number of AI factories, and the biggest one is under build is the Applied Digital. You can look, there is a ABB and Applied Digital white paper available as well. So there are ways to take care of those unpleasant peaks, let's call that.
Indeed. Let me just check. Nothing more. I have my own question, actually. I'm going to read it out. Sure. So your slides, they show a very large portfolio. So from rack levels for centralized UPS, lithium ion, I think lithium ion is becoming the standard. So thermal risks concerning the thermal density as well. Where does the balance sit between maximizing energy density, but to also ensure the safety of the facility itself?
Yes, and I've been not only 15 years with data centers, I also had the chance to follow the energy storage curve since 2007 in ABB. I was leading part of that unit, and the technology has significantly changed. The batteries or technologies that we discussed in 2010 is completely different than today. They are more safe. The way we build them is also, we consider the thermal runaways. We put it on the fire, protect the buildings. The fire systems are completely different. So the way we build the things today is pretty safe way. Of course, the lithium is sometimes the questions, but the good thing is, like 15 years ago, there wasn't any regulation about it. Now we know it. Yeah. Standards are in a place. And as I said, there are also technologies which are not so bad like it used to be the lithium ion, right? So we don't produce in ABB the batteries ourselves. We work with the different vendors, and we are kind of technology free on the battery, choosing the right battery. So if customer has a clear view on battery technology, it's okay for us. So
perfect. We got one more question. We'll make it a quick one. So the question says, do ABB have an RPP panel rated above 1,000 amps, 1,600 to 2,000?
Yes, we do. Yes, we do. We have a different option for RPPs. If it's needed with a touch-proof busway and so on, then we do have a certain limit. I think the limit was on the 1,000 amp, but we also can do the higher rating than that. So if you can find any information on the webpage, reach out to me. I'll get you to the right place. So, but we do have, yes.
Perfect. Fantastic. I think that basically wraps it up perfectly. Danel, thank you so much for your time. I really appreciate it.
Thank you. Bye.
Yes, thank you.